Okay, hello everyone. Alright, so today we'll be looking at a new type of calculation. It's called the volumetric calculation. So volumetric is basically talking about volume of solution. Now, a lot of students make this mistake because they are confused between the volume of solution and volume of gas. So please take note that this is not volume of gas. So volume of gas calculations, you will use the molar volume, which is 24 dm cube. However, in this situation, we are talking about volumetric calculations of volumes of solutions, and in particular, right, acid and base reactions. So we have all actually completed our titrations in the lab, and the volumetric calculations actually help you do the calculations required for titration. So let's just take a look. All right. So first one, a solution of 25 cm cube of nitric acid was titrated against a standard solution of 0.1 mole per dm cube potassium hydroxide. What does this mean is that if I have, please draw with me, I have a burette and then I have a conical flask at the bottom. In the conical flask, I have 25 cm cube of nitric acid. Okay, and then in the burette, I have potassium hydroxide, which I know 0.1 mole per dm cube. And then throughout the experiment, I found out that actually 20.8 cm cube of the potassium hydroxide is required for the full neutralization, right? And usually in volumetric analysis, they will then ask you to calculate something about the one inside the conical flask. So we have a very specific way of doing these calculations. So I'd like to show you the working that you should have. So remember when we are doing the concentration calculations, I always ask you all to write it in alphabetical order, right? C, N, V. C equals to N divided by V. So now we have, what we do is that now we have two chemicals. We have potassium hydroxide and we have nitric acid. So I'm going to label KOH, okay, and then CNV, and then HNO3, nitric acid, CNNV. Right? So now what we're going to do here is that we're going to fill up this information with what we have already. So do I have the concentration of KOH, potassium hydroxide? So if you look over here, this is the concentration of potassium hydroxide. So I'll fill that in, 0.1 mole per dm cube. Next, do I have the number of moles, N, of potassium hydroxide? So let's take a look. Oh, don't have. So let's put a question mark mole here. Do I have the volume of potassium hydroxide used? So we can see over here, I'm given 20.8 cm cube of potassium hydroxide. Yes. So I'll write 20.8. And remember, because we do all calculations in dm cube, immediately divide this by 1000. Okay, do yourself a favor. Immediately divide it by 1000. Now, let's see what information do we need for the nitric acid. So in nitric acid reading, I know that there is 25 cm cube of nitric acid. This is the volume. So let's write here 25 and immediately divide by 1000. And that's all the information I'm given. And I need to calculate the concentration of the acid over here. Question mark dm cube. And I do not know this also. And this is what I want to find. So you realize that actually on the potassium hydroxide, I only have one question mark. And in an equation, if I have only one unknown, I can easily solve it. However, if I have nitric acid, right, I have two question marks. So it's very hard for me to solve. So which one do you think I should start with? Right? I should start with the potassium hydroxide because I only have one question mark over here. Okay? So the strategy of doing this question is the same as the calculations that we've been doing. There's always 3 steps. Right? So first, I need to find the number of moles of my first one. So we decided to find KOH. So the number of moles of KOH. And then I use mole ratio for step 2. And then in the third step, I find out whatever they want. They want over here, I want concentration of the acid. Okay, so let's start. Right, so using the information I'm given, remember that C equals to N divided by V. So given the information I have, let's just write first, C equals to N divided by V. I'm given C, 0.1. I am not given N, and I'm given V, 20.8 divided by 1000. Right? So using a good math and proper calculation, I will have noticed that my N would be 0.00208 moles. Okay, so I'm going to erase what I've written up here. So I found out that the number of moles 0.00208 moles. Now I need to find, using mole ratio, the number of moles of nitric acid. And from the equation, I know that the mole ratio of KOH is 1:1 HNO3. So I can just write this down over here. 0.00208. Be careful, there will be a lot of zeros. Okay, equals 0.00208. Okay, so I can adjust my working here, 0.00208 moles. Right, so now I am given all of these values. I should be able to find, right, the concentration of the nitric acid. So remembering that the formula is C equals to N divided by V, I write it down, C equals to N divided by V, and I substitute my values, and then I do the math. So I will get divided by 0.025. The answer I get is 0.0832 mole per dm cube. Alright, so I hope if you don't understand this, please watch this video again. If not, please practice this question or try the next question and then watch the videos that I've made to check your answer. Okay, all the best. Bye-bye.